the steps you should be able to follow through to get to a product. Dilute chloride is a reagent that replaces an OH with a chlorine, right? So if you use them with a carboxylic acid, you are making acid chloride. That's a good living group. And then you got an amine as you profile there. So what we can expect, this makes an attack. Of course, it'll make a tetrahedral intermediates. And then this electron pairs coming back and take the chlorides out. That's kind of my way of showing the steps down. I guess you could do this if you don't want to keep drawing the tetrahedral intermediates. After you'll be tired of doing that. So it makes an amide. So that is a very simple reactions. The second one is you are making ketones from the carboxylic acid. After seeing the previous slide, this becomes pretty simple. But the thing is that after a month later, we will be able to remember this reaction. Okay. So we need to introduce these 4 carbon chains. So that's where we need to introduce that. First thing is, yes, you have to convert the carboxylic acid to something else, like acid chloride. That's needed. So dilute chloride treatment is needed to convert the carboxylic acid into acid chloride. You need a new compound with a 4 carbon chain there. But not the greener, because if you're using a greener necessarily, greener will make an attack, kick the chlorides out. You initially have these forms, but this will react again if you get torsion out. I keep mentioning that, so don't use a greener. So a better way to do it, if you're using less reactive forms, which is diethylcurate, is diisobutyl cuprate, we'll put these diisobutyl groups there by kicking the chlorides out. So that's the way to do it. Yeah, this is not a new reaction. We have seen this before. But there are so many, so that's the question. We should be able to learn this. Making ester, if you ever see this question, you never have one. This is so many information to make it happen. If you have a carboxylic acid, they can add ethyl ester. Well, putting on ethanol, acid, cook it up, that's a Fischer acidification, absolutely that will work. Another way, converting the acid to the acid chloride, which makes it more reactive. So you don't need an acid, you just simply drop the ethanol to that, then it'll make that. Third way is you putting some base, it could be any base. Sodium bicarbonate is really cheap. That's baking soda. It's a ton available, really inexpensive prices. So people use baking soda a lot. That takes those protons off, making the carboxylate. That's better than profile. You need to just the ethyl as an alkyl halide, to make an ethyl profile. It makes an attack, kick it out, then it's just nothing but SN2 reaction. But you can also make that in another way. So there's a multiple different way to get the same thing done. You can choose either of these 3. Converting the acid into the aldehyde, again, we just talked about that. You have a fresh memory. So this won't be too big a problem. But question is the time capacity is like 3 weeks later. You can do 2 different ways. One, completely reduced carboxylic acid into the alcohol, then oxidize it with the PCC, PDC, Collins, Swan oxidations. That will convert the primary alcohol to the alcohol. That's what we'll do. Second way is, reduction can be done by the borate too, just in case, there's some reason for borate. Really selectively reducing carboxylic acid to the primary alcohol, even though it may have other organelle as a ketone or alcohol. So that's the one way. Another way is you convert the acid to the acid chlorides they use the very, very weak aluminum hydride. That is the tri-keetoxy aluminum hydride. That's very special because it's weak, and that's only replacing the chlorine of the acid chloride, and then only makes an aldehyde. And then it doesn't even react with an aldehyde. So it's really good. So that's is kind of a thing I want to show you here, why the ways worth knowing. Let's say you have to reduce this carboxylic acid only, not that. Then this is where the borane is going to be useful. If you're using the aluminum hydride with that, yes, that's going to be reduced to this, but the secondary alcohol is going to be there too. So without that complication, only thing you can use that's a borane. If you use a sodium borohydride, sodium borohydride is weak, so you can reduce this ketone, not reduce the carboxylic acid. So you get that. So you are making different things depending on what reductant you use. The borane, very selective to carboxylic acid, you only reduce this part, not touching that part. So you have different solutions here. And then we talked about also if you kind of convert that ketone to an acetal, you protect it, and then you can use a aluminum hydride to reduce that to the primary alcohol. Then you got then break it out by the heating of with an acidic water. It's a longer step, but it can be done. So, if you don't have a borane in the lab, then it's just sort of aluminum hydride.